Hello everyone, welcome to our Smart Agriculture Connectivity Planner. This is a cutting-edge tool designed to revolutionize agricultural planning and connectivity. Our project aims to empower farmers, agricultural planners, and stakeholders with a data-driven insight and tools to optimize connectivity and resource allocation in agricultural areas. The problem statement: agriculture, as we know, is the backbone of many economies. Farmers and agricultural planners face significant challenge in optimizing connectivity and resource allocation. The key issues include limited connectivity, like rural agricultural areas often lack reliable communication network, making it difficult to implement smart farming technology, and also insufficient resource allocation. Without proper planning tool, farmers struggle to allocate resources like water, fertilizers, and equipment efficiency, and also lack of data-driven insights. Many agricultural decisions are made based on intuition rather than data, leading to suboptimal outcomes. So our Smart Agriculture Connectivity Planner app addresses this challenge by providing a comprehensive platform for geospatial analysis, networking planning, and cost simulation, and data-driven decision-making. The project was developed by a talented team of 5 members: Muhammad Hanzala, Amira Said Muhammad, Nimbura Gashahi, Amina Arouj, and the last member is Khurram Hanif. So, our solution, the Smart Agriculture Connectivity Planner, provides a suite of tools to address the challenge faced by farmers and agricultural planners. We are providing geospatial analysis. The user will upload geospatial data to analyze terrain, vegetation, and elevation, and visualize data on an interactive maps with custom parameters like vegetation, threshold, and elevation range. And we also will make a network design, plan optimal communication network like LoRaWAN, 5G, and satellite based on budget and terrain complexity and technology type. And we have get an AI-powered recommendation for equipment, coverage, and maintenance. And we also have offered in our app cost simulation. We will simulate costs for equipment, installation, maintenance, and lessons. And we also will visualize the cost breakdowns and ROI projections. And we also will offer a dashboard. User will access the centralized dashboard for data-driven insight and visualization. He can monitor key metrics like total area, vegetarian cover, and cost breakdowns. The technologies have been used. We have used the front end, Streamlit, Plotly, and Fully. And the back end, we have used Python, OpenAI, and GeoPandas. In data visualization, we have used the Plotly, Express, and Matplotlib. And deployment, we have used Streamlit Cloud and GitHub. You can run this project using this command. Let us run our project and see how it's run. We will write Streamlit run app.py and press enter. He will get us to our app. Here it is, our app, Smart Agriculture Connectivity Planner. Here it is an information how to use this app, navigation and features, and how to use a network design, cost simulation. This is what we offer, and dashboard, and the key benefits, and the support, and if you want to contact to the creator. And here it is our navigation tabs. Instruction, this is our tab, and geospatial tab. If I press on geospatial tab, I will direct drop file the data. I will get the data from here, and here it is. We can zoom out or zoom in the terrain visualization, and we can see here the total area, average elevation, vegetarian cover. And if we are gone into the network tab, you can here put your budget, what budget you want to do, and the AI model also, what AI model you want to use, and the technology you want to use, and the terrain complexity. You can choose from here, and then you will generate a plan for you. Here he is generating a plan for you. Here it is our very technical plan. He will tell you route placement strategy and signal propagation and recommendation equipment, LoRa arrays, and here it is also a graph of cost projection and number of nodes. If we get onto the tab of cost, We will also put the area size as we want, and the deployment strategy as we want, and target population and the technology we want to use. And I will tell him to simulate costs. See, he have simulate my costs, and row timeline it will be 3, about 4 years, and the node required is 2, and here it is the cost of each thing, the cost of everything, and here it is the graph. Also, it is cost to comparison by deployment strategy. And if we are going into dashboard tab, we can see our dashboard tab, the network coverage. You can zoom in or zoom out, and here it is the performance over time. You can see performance here from this graph, and you can see also the row analysis. That's our app.